Alright guys, welcome to complex conjugates of complex numbers. The essential understanding today is going to be able to use conjugates to calculate not only the absolute value of a plus bi, but also to help us divide complex numbers. Okay, so the first thing we really have to know is what is a conjugate. So if we let z be a complex number, a plus bi, the conjugate of that is a minus bi, and we denote it as z bar. Okay, so if you can't see that, it's z bar. Okay, for example, the conjugate of 4 plus 7i is 4 minus 7i. Notice the real part's the same, the imaginary term is the same, it's just the operation that becomes opposite. So think about that, and that's going to be very useful later on. Now, in the second slide here, we're asked to complete the table. I've gone ahead and done that because there's a really important thing here that we're going to deal with, and it's this idea. Okay, what happens if we multiply a number and its conjugate? So here are my four real or complex numbers. Okay, 4 plus 7i, 5 minus 2i, 3i, and negative 6. So let's look at their conjugates. 4 plus 7i is 4 minus 7i. 5 minus 2i is 5 plus 2i. 3i becomes negative 3i, and negative 6 is itself, because there's no imaginary part. So plus 0i would become minus 0i. It's still nothing. Plus nothing, minus nothing. We just leave it off. Interesting, when we multiply conjugates, we get a positive number. Positive number, positive number in this case, positive number in this case. And that's not by accident. So how do we get these numbers, 65, 29, 9, and 36? Well, let's just look at the middle value here, or one of these. If we squared 5 and we squared 2, we would have 25 plus 4, which gives us 29. Either one of these, 3 squared, is 9. I could take negative 3 and square it, and I get 9. So there seems to be a pattern. Negative 6 squared, 36. And even 4 squared and 7 squared being 65. Leads us to this nice property. Basically, when you multiply conjugates together, the a plus bi times a minus bi, that's the same thing as just taking a squared plus b squared. That's going to be very useful when we divide complex numbers, and it's going to lead us into the discussion with absolute value. With absolute value, when we talk absolute value, we're talking about the distance a number is away from 0. Now that's if you have one variable, like 7. Let's say 7. 7 is 7 units away from the origin, or away from 0. But if we talk about a point in the plane, absolute value becomes the distance you are from the origin. Okay, it's a point, wherever you are, and that point, if we go out x and up y, or in this case out a and up b, we're still the distance from 0. We're talking Pythagorean theorem. So the absolute value, denoted as with the vertical bars with z, is equal to the absolute value of a plus bi. That just becomes the square root of a squared plus b squared. That's how you find absolute value. And we can look at the drawing. The absolute value of a is a distance, and we can use that to find the hypotenuse, which is the distance from the origin, which is the absolute value of our complex number. So let's look at two examples. 3 plus 4i and 1 minus 5i, we're taking the absolute values. So just identify your a and your b term and square them, which is what I've done here, and put that all under a square root. 9 and 16 make 25. The square root of 25 is 5. At that point, 3 over 5 up is 5 units away from the origin. 1 minus 5i becomes 1 squared plus 5 squared under the square root, and that becomes root 26. Now looking at these two here and here, I know that this number is further from 0, from the origin. Okay? So that has a larger absolute value. So that's how we use complex numbers and how we find their absolute value. Just square the a term, square the b term, put that under a radical. The sign does not matter because you're squaring the numbers anyway, and that output will always be positive. Now, here's the big kicker here. This is the more complicated part, dividing complex numbers. We know what conjugates are. We know how to multiply. We know how to add complex numbers. So now we can look at this division. Division of a complex number looks like this, a plus bi over c plus di. Okay? So to divide those, we multiply the whole fraction of the quotient by the conjugate and simplify. So let's look. Here's my first complex number, if we cover that up. 6 minus 4i, all divided by 2i. Well, to divide that, we're going to multiply the numerator and denominator by the conjugate, which is here in red. Now, it's not the conjugate of the whole thing, it's just the conjugate of the denominator. The conjugate of 2i is negative 2i. So when we simplify, you got to be careful. 6 times negative 2i is negative 12i. Negative 4i, or minus 4i, times negative 2i is negative 8i squared, becomes negative 8. So we just distribute. You have 6 times negative 2i minus 4i times negative 2i. This becomes 8i squared, which is negative 8. 2i times negative 2i is negative 4i squared, which becomes 4, right? Because I squared is negative 1. And then 4 goes into 8 and 12, so that gives us negative 2 minus 3i. Now, let's look at 2 more examples, because that could be confusing. Here is another complex number, 10 minus 15i over 2 plus I. To simplify, I multiply the whole fraction, the whole quotient, by the conjugate of the denominator, 2 minus I, which is what I've done here. Now, you know how to multiply fractions. You'd multiply straight across. You also know how to multiply complex numbers, so we do that. So really, that top would be 10 times 2 minus 10 times I minus 15i times 2 minus, it will be plus 15i squared. Okay? And then I would simplify. I've gone ahead and done that here. I went ahead and didn't show all that work, but that's the idea, multiplying straight across. 2 plus I times 2 minus I, those are conjugates. Square 2, square 1, 4 and 1 make 5, and that's where that denominator comes from. Okay, the end result here is 1 minus 8i. The last example, we have 1 in the numerator, so that's a real number, but it is complex. The denominator is 2 plus 2i. So I'm going to multiply the whole thing by the conjugate of that denominator, which is 2 minus 2i. The numerator is easier because you're multiplying by 1, so it's just 2 minus 2i. The denominator, look, just square that term, 4 plus 4 is 8. And we can go ahead and simplify that to 1 minus I over 4. So that is using conjugates to help divide complex numbers and finding absolute value of complex numbers. If you guys have questions or comments, you can email me at nicholas.bennett@dc.gov or just type them in the comment box. See you next time.